The purpose of this study revolves around an enigmatic event in architectural history, the collapse of World Trade Center Building 7, also known as WTC-7. Unlike its counterpart buildings, WTC-7 was not struck by a plane on the tragic day of September 11th, yet it experienced an abrupt collapse. This raises a critical question. Why did it happen? The National Institute for Standards and Technology, abbreviated as NIST, released a report in 2008 asserting that the combination of fires within the building caused the failure of its structural elements. According to NIST, the heat from the fires resulted in the thermal expansion of floor beams and girders, which set off a chain reaction leading to the total collapse of the structure. However, there are dissenting voices in the engineering community who contest this conclusion, positing that fire alone is not a plausible explanation for the failure experienced by WTC-7. Consequently, this study was initiated to delve deeper into this controversy, specifically investigating the pivotal query: did fire indeed cause the collapse of WTC-7? This began with the assembly of all available documents related to the building, including its erection drawings and various design documents. Using AutoCAD software, a comprehensive virtual model of the building, which stands at 47 stories tall, was created to facilitate further analysis. Following this, sophisticated modeling software, abrupt, was utilized to prepare non-linear models for the various connections within the building's framework. Further analyses were carried out using both SAP 2000 and abrupt to assess specific framing sections, particularly floors 12 and 13, for fire damage and to study the potential for a progressive collapse. The virtual model proved instrumental in simulating the conditions that prevailed on the fateful date of September 11 in 2001. As of the data presented on September 6, 2017, the findings of the study are to be peer-reviewed and reveal intriguing conclusions. The first part indicates that the study found no evidence to support the claim that fire was responsible for the collapse of WTC-7. The results obtained from advanced simulations using abrupt and SAP 2000 indicate a different narrative. The second part of the findings highlights that the analyses regarding the possibility of a progressive collapse are nearing completion. This aspect remains under investigation with the continued application of SAP 2000 and abrupt. To provide some context, WTC-7 was constructed from 1983 to 2001, reaching a height of 47 stories. It was designed by Emery Roth & Sons, featuring a prominent red granite facade. The geometry of the building was characterized by a trapezoidal footprint, standing tall at 610 feet, with dimensions of 330 feet in length and 140 feet in width. The construction process was initiated in 1983, and the building officially opened in May 1987. Its foundation was unique, as it was built upon caissons that extended through a Con Edison substation, originally retrofitted to support a future 25-story building. The building's framework was ingeniously devised, consisting of a system of gravity column transfer trusses and girders located between the 5th and 7th floors. The 5th floor fulfilled the vital role of a structural diaphragm, guaranteeing both lateral stability and effective load distribution between the older and more recent caissons. Above the 7th floor, the building adopted a typical tube frame design, incorporating columns within the core and along the perimeter, with lateral loads managed through perimeter moment frames. The timeline preceding September 11, 2001 shows WTC-7 situated about 350 feet north of WTC-1. On that infamous day, despite not being struck by an airplane, WTC-7 sustained significant damage due to the fires that ignited within it. The documentation reveals that fires were reportedly observed on multiple floors, including floors 7 through 9, 11 through 14, 19, 22, 29, and 30, according to NIST data. Notably, it is emphasized that there was no evidence of fires occurring below the 7th floor 1 hour before the building's collapse. This research posits that fire was not the cause of the collapse of WTC-7, which stands in opposition to the interpretations presented by NIST. The presentation will delve into the NIST methodology as well as the research team's own approach and findings, fostering a comprehensive discussion on the subject. As for what lies ahead, the ongoing progressive collapse analyses remain a priority. The assumptions and claims posed by NIST are foundational for the analysis conducted by the University of Alaska Fairbanks team. NIST maintained that the collapse was instigated by fire-induced weakening of critical columns, suggesting the high temperatures reached in the beams and columns led to significant structural compromise. For instance, they indicated that beam temperatures reached 600 degrees Celsius, whereas girders were documented to have reached 500 degrees Celsius, with column temperatures at around 300 degrees Celsius. However, this analysis faces scrutiny, as it is noted that no deformation was observed in the east exterior wall due to the thermal expansion of vital beams and girders. The absence of shear studs on the girders has sparked debate among professionals, and the broken shear studs on several beams further exacerbated the complexity of the findings. The details of these connections and their performance during the fire are under intense examination. In examining the results derived from NIST's computer models, it becomes evident that certain assumptions, such as fixing exterior columns in every direction, may not align with real-world conditions. Within this dialogue surrounding the collapse, NIST's conclusions are seen to conflict with emerging evidence, particularly the absence of substantial deformation in the actual collapse observed. The research team from the University of Alaska Fairbanks conducted a solid model analysis of the structural members to explore the claimed events laid out in the NIST report. They focused on the behaviour of girder A2001 as it was purportedly pushed or rocked off its seats at columns 44 and 79, purportedly initiating the collapse of WTC-7. This thorough investigation is essential for understanding how structural dynamics interact under extreme conditions. The findings have revealed discrepancies in NIST's claims, particularly in their analysis of connection failures and the effects of thermal expansion. By utilizing advanced finite element methods, the University of Alaska Fairbanks has sought to provide a clearer picture of the collapse's mechanics. Analyzing the interactions of various structural elements reveals critical insights into the building's response during the catastrophic event. It is crucial to highlight that while NIST attributed the collapse to thermal effects resulting from fire, the University of Alaska Fairbanks analysis suggests a more complex interaction between structural members and their surrounding environment. As this ongoing discourse evolves, it opens the door for rigorous peer review and public commentary, emphasizing the importance of collaboration and transparency in understanding the events of September 11th. Consequently, the growing body of evidence suggests a reassessment of the assumptions laid out in prior reports, particularly concerning thermal effects and their interaction with structural systems during critical failure events. The path forward entails a thorough examination of progressive collapse scenarios driven by various potential conditions and failures, ensuring that lessons learned from WTC-7 contribute to future engineering practices and safety measures in similar large-scale structures.